So this PowerPoint is going to be talking about television technology and its beginnings. So television is a technology that really engineers, technicians around the world had been working on. This was kind of the next step beyond radio. We have voices and sounds that can come across the airwaves. Now, how do we put pictures to that as well? And early television technology uh, looked to previous technology as an exemplar. That is film. Film is basically long strips of plastic that is light sensitive that have little pictures on it, and that those long strips of plastic are run through something that projects those small pictures, and as the pictures are being projected, the motion of the film suggests that there is motion in those images. So it's really light being or pictures being projected with light onto a screen, and that was the idea behind early television technology. That is that it was going to be mechanical. It was going to be light projecting images on a screen. That really didn't work. Didn't work at all. So instead of being mechanical, and we've talked about this, the difference between mechanical and electrical is that mechanical tends to have a physical presence, whereas electrical tends to have more of a light source to it. How the new television technology began is kind of there has been a level of controversy to this, but to understand the controversy, we have to look at really how television works. If you look at a television screen, it is not one solid picture. Rather, it is made up of little points of light, little dots of light, and those dots change color if it's a colored television, or they change grayscale, brightness or dimness, if it's black and white. These little dots are called pixels. If you've done any still photography, you know that the image is made up of little points of color, basically the same thing. So pixels are what the images of television are made up of. But those pixels need to be in a particular configuration, and these are lines of pixels, basically lines of resolution. What happens is the first pixel starts at the top of the screen, top left of the screen, goes across the screen for the first row, and then goes back for the second row, third row, fourth row, all the way down to the very end of the screen. Once you have one full screen, that is a frame. So a frame is one entire screen of pixels in lines of resolution. Once that frame is done, the pixels go back up to the top left of the screen again and start over. So television images, like film, are basically made up of a series of frames. The question in the early days of television was who actually came up with this idea first. The man who is credited with this is Philo Farnsworth. Farnsworth was, as a kid, was a tinkerer. He liked to work on mechanical problems. He liked to put things together. His family were farmers, so that of course meant that he had to do chores. One of which was planting fields of crops. And one day, as he was on the tractor and he was out planting rows of a particular crop, he thought about the potential application of the idea of planting seeds to a television screen. How do you really, what's a better way than, other than putting up, one flash of an image, what's a better way of putting that image together? And so he came up with this idea of, instead of using one solid image, starting with little colored or black and white dots and doing them in rows. So you had electronic lines of dots as opposed to one solid image. And then once the screen was full of all of those lines of those dots, it would start over and start a new frame. Farnsworth actually came up with this when he was a kid at the age of 13, back in 1918. And he took this idea to his chemistry teacher when he was in junior high or middle school. And he had drawings and schematics of it, and his chemistry teacher actually helped him develop this idea into how do you create images on an electronic screen by imposing dots and lines of resolution. Eventually, what he came up with was the image dissector. The image dissector is really a camera tube. It is inside a television camera. It is what captures the image. It's what captures the light, the light waves that come in, and then turn those light waves into a different type of energy, that is electronic signals. And those electronic signals go through a wire into something that is going to take that scene that's in front of the image dissector and create an image on a screen, a display, electronic display. And this is the image oscillate. So you have the image dissector, which finds the image or creates the image, turns it into an electronic signal that goes to the image oscillate, which is going to display that image. The image oscillate then is the first television picture tube. So by 1927, Farnsworth has really the first working television system. You have a camera that is going to capture the image, and then you have the television that is going to display the image. He receives his patent in 1930. But like I said, he wasn't the only one working on this. There were other technicians really kind of around the world who were also working on this technology. One of them was a Russian student, engineering student at Moscow University named Vladimir Zworykin. He'd been working on this technology as a student, but he emigrated to the United States and started working for RCA, which was the parent company of Westinghouse at this point. What he comes up with is the iconoscope, and of course, with the support of David Sarnoff, who was the head of RCA. The iconoscope is another kind of camera image tube. It's taking a scene and taking that image and turning it into electrical current that is then going to be displayed on another technology. They apply, as Westinghouse, they apply for a patent in 1923, but don't receive the patent until 1938. This, of course, sets up a conflict between Farnsworth and RCA and Westinghouse with Zworykin and Sarnoff. RCA, of course, argues that Farnsworth has stolen the technology, used their technology in his patent, and of course Farnsworth countersues, saying that no, he was the first one to come up with this technology, and he has his patent should be solely owned by him, and that Farnsworth or Zworykin and RCA are infringing upon his patent rights. What happened was in the trial, Farnsworth, in testimony, brings with him and includes in his testimony his drawings as that he had made as a very young teenager back in 1918, and actually. One of the people who testifies for Farnsworth is his old chemistry teacher, who was working with Farnsworth in the early television technology. Well, Farnsworth wins the suit, but what he understands is that even though he has the patents to this technology, he really doesn't have the capability, the facilities to take this technology forward and really make something out of it. And so what he does is sell his patents to RCA and Westinghouse, who then, of course, start using them as the basis for their television signal technology, as well as receiver technology for television systems. Eventually, the iconoscope becomes the standard for television tubes, what are known as cathode ray tubes, in a television set. This is the big tube that is the picture tube that the image comes out on, that we watch, that we see. The iconoscope really became the standard simply because the image dissector, the one developed by Farnsworth, its major problem, even though Farnsworth developed it first, its major problem is that it needed a lot of light in order to create that image, and to display that image. It really needed a whole bunch of light, so much light that for anyone to stand in front of the light would actually be uncomfortable. It would be very, very warm, very, very hot. The iconoscope didn't need that much light in order to create the image. Another bit of trivia for Farnsworth: the first image that he displayed on his television system was a $sign. So where we are as far as the 4 elements of audio and video mass medium to be successful for television is that the technology has made a step forward. We have the technology itself, that is the exhibition technology, that is images can now be created, can be put together, and then displayed in the exhibition on television sets. But all the other elements haven't yet really progressed far enough to make television really into a successful mass medium. So other things need to be put together, need to be developed in order for television to be a true mass medium. Distribution, the idea of coming up with cameras and television stations, that's being developed, that's on its way. And certainly the exhibition, the television cameras and the television sets, the technology for that is understood and can now be manufactured. But again, probably the most important part of those four elements, standardization, has yet to be determined. In order to determine how things would be standardized, a committee was formed called the National Television Systems Committee. This committee was formed in the 1930s, and the idea was for technology companies, how would this technology, what would be the standards for this technology? What would be the signals frequency? What types of cameras would need to be made, and then what type of receivers, televisions would need to be made? What were the standards for all of this technology? What the NTSC came up with was, first, there would be 525 lines per image in each frame. Remember, the frame is the pixel starting up in the top left corner, goes through one line of resolutions, then 2 lines, and 3, all the way down to the bottom right corner. So what the NTSC determined is that there would be 525 lines of resolution per frame. Then they determined that there would be 30 frames per second. So each second of a television image would be divided up into 30 frames of 525 lines per frame. The final standard that they settled on was that in these early days of television development, any sort of television signal sent out from a television tower, from a TV station, to a receiver in a community would only be a black and white signal. That is, the images could only be conveyed in black and white. Early color television had been worked on. It had been born, but the problem was that it wasn't really stable, and so the problems were that it just wouldn't last in the same level of quality as black and white signals would last. So these were the standards that the NTSC came up with, and speaking of NTSC, you can, these are the standards that really stayed with television technology into the 2000s, when these are also known as standard television, STV. These standards were adopted in 1941 by the Federal Communications Commission, which had by this time been given responsibility for the standards and regulating television signals as well, just as they were also given responsibility for regulating radio signals. Like I said, the NTSC standards really went up to the 2000s, and so you can go to I'd say go to if your parents have a VHS camera around, you can look at that and you'll see on the side or on the bottom that camera will meet NTSC standards. What you have to understand, though, is that these are only U.S. standards and really North America standards. In the United States, because our borders are basically open with Canada and Mexico, Mexico and Canada have accepted the same standards. Why? Simply because they are bordering the United States, and television signals really don't know borders. So you may have television stations on in Texas or in Arizona that are sending signals across the Mexican border into Mexican towns and cities. And so how can you get those signals? or how can you, I mean, and those signals can be pretty dominant. So consequently, Mexico and the same thing with Canada. So Mexico and Canada understanding that the signals of American TV stations are going to leak across their borders. They accepted the same standards, and of course, Canadian signals and Mexican television signals can leak across American borders. These standards are also the standards for a very large part of the Pacific Rim countries like Korea, Japan, the Philippines, parts of China, parts of Southeast Asia. Why? Primarily because of World War II. After World War II, hundreds of thousands of American troops were stationed in Japan, and of course with the Korean War in the 1950s, troops have been stationed in Korea, in the Philippines for decades now. They want to watch American television, so basically American television standards were introduced to these during the rebuilding process after World War II and have been there ever since. European standards, on the other hand, are different. European standards developed on their own, particularly pre-World War II, while American standards and North American standards are 525 lines of resolution per frame. In Europe, it's 625 lines, where there are 30 frames per second in American standards. In Europe, it's 25 frames per second. This is basically what's known as the PAL system, P-A-L. This is also the reason that if you have ever tried to send a videotape, or if you've ever made a DVD, a video DVD, and tried to send it to a friend or a relative in Europe, they may have contacted you back and said, I can't play it, it doesn't play on my machine. That is the reason that it couldn't play, is because it's basically a different format. What has happened really again in the 2000s is with the more popularity of video editing software, you as an editor have a choice. You can either put your final video product in the American NTSC system format, or you can put it in the PAL European format, so that your if you did have an international audience, it could be played on the technology that they have available there. So now we're getting into the a couple more of the elements being present in the audio and video mass medium success story. We're starting to get some standardization. Television sets, the signals themselves, the receivers are starting to go into mass production. There is starting to be a push for more television stations to be built around the country. So by the late 30s and early 40s, it is believed that television is going to be the next technology that is ready for the mass market. But of course, like in World War II and like other media and technology related to media, everything is kind of put on hold. All kinds of communication technology are now put towards the effort to winning World War II. After World War II, it was expected that this new technology, this new medium, was ready to enter the mass market and really just take the whole consumer market by storm. But that isn't really what happened. After World War II, there were two levels where there were significant problems that needed to be dealt with before television could become go into the consumer market and become popular. How were people in the whole country going to have access to this new technology? And for it to work, the entire country had to have access to it. What the FCC was finding is that early applications for television stations were applications for building TV stations mostly on the West Coast and on the East Coast. Why these particular areas of the United States? Population. New York City, Washington, D.C., Philadelphia, Boston, these are all large eastern population centers, whereas Los Angeles, San Diego, San Francisco, these are large West Coast populations. What the FCC wanted to do was not just make television available to the East Coast and the West Coast, but also to Eau Claire, Wisconsin, Casper, Wyoming, Zanesville, Ohio. What the FCC wanted is that television should be available all across the country, not just in large populated areas. So what they determined was we want the American people, everyone in the United States, to have access to at least one television station. So the rule that they made was that if you were applying for a station in a location like Eau Claire, Wisconsin, or La Crosse, Wisconsin, or Casper, Wyoming, or Zanesville, Ohio, you were going to get priority because they wanted to make sure that there was geographical equity. Television was available to all the communities around the country. At least one station was available to everyone in different places. Previously to World War II, the FCC had decided that signals generated by television transmitters would only send out signals that could generate black and white images. Through the war and through a couple of years in the post-war, color signals had been more highly developed, consequently had become more stable. And so the question for the FCC was, do we stick with the just black and white generated image technology, or now can color technology, image technology be transmitted as well? There were two companies that had color signal technology developed. One was CBS, the other was NBC. CBS's signal could only be seen on color television sets. That means if they adopted the CBS signal, that would mean that the customers, the viewers out there, if they had a black and white television set, they would have to buy another television set that could accept color signals. NBC's, on the other hand, its signal could be seen on both black and white sets and color television sets. So, of course, the FCC adopts the NBC color television signal. And by 1954, NBC starts putting color programming onto their programming network. What they did, simply because some of the programs were in black and white, some of the programs were in color, NBC alerted the viewers of their network which programs were going to be in color at the beginning of those programs.
The following program is brought to you in living color on NBC.
And this is actually where the NBC Peacock
The following program is brought to you in living color on NBC.
That the next program is going to be in color as opposed to being in the black and white form. By 1966, all three networks had color programs, and each had really its own way of informing the audience which of the programs were going to be in color versus black and white. By 1952, both the government and the networks have really kind of worked out their problems. And in 1952, the FCC lists its license freeze. So that's the beginning of television technology.